Hi everyone, this is Maverick Phua, the chemistry guru. Now in this video, we want to run through the suggested solution for 2020 A-Levels H2 Chemistry Paper 1, question 11. Now question 11 goes something like this. Changes in temperature can affect the spontaneity of a reaction or the feasibility of a reaction. Which statements are correct? So we have three statements here. Statement number one, if a reaction is endothermic and has a negative entropy change, the reaction is spontaneous at all temperatures. Statement number two, if a reaction is exothermic and has a positive entropy change, the reaction is spontaneous at all temperatures. And finally, option three, if a reaction is exothermic and has a negative entropy change, the reaction is not spontaneous at any temperature. Now clearly, you notice all these three statements is talking about these three terms that we learn under energetics or thermodynamics. Endothermic or exothermic, it is related to enthalpy change, delta H term. And if I consider entropy change, positive entropy, negative entropy change, then we are talking about delta S term. And finally, when I consider whether the reaction is spontaneous or not spontaneous, then we are linking this to delta G, Gibbs free energy. And we are using the sign of delta G to predict feasibility. If delta G is negative, the process is feasible. If delta G is positive, then the process is not feasible, correct? So the topic tested in this exercise, again, is under energetics or thermodynamics. What we are focusing on is predicting feasibility or spontaneity. And the expression that we're using is this delta G equals to delta H minus T delta S. So delta G represents the Gibbs free energy. Delta H represents the enthalpy change. T is temperature in terms of Kelvin, so we should be familiar with that. The delta S term, it is the entropy change. So the signs of my delta H and delta S terms are all given. So what we need to do is we need to substitute into this expression and we try to deduce, okay, what will happen to delta G? Is it always positive, always negative? Positive at higher temperature or positive at lower temperature? So based on changes of my signs of delta G at different temperatures, then we can predict the feasibility or spontaneity of a process at various temperatures. So we are able to do that if I have the information involving the sign of delta H and the sign of delta S. All we need to know is this equation. We need to use it for calculation anyway. So this question is actually fairly simple if we just make use of this equation. Now let us run through this part by part. Statement number one, let's see whether this is true or not. If a reaction is endothermic, which means that my delta H, it is a positive term, and has a negative entropy change, which means that my delta S, it is a negative term. So the reaction is spontaneous at all temperatures. Let's see whether this is true or not true. Now my delta H, using this equation, delta G equals to delta H minus T delta S. Delta H, it is a positive term. Delta S, this is a negative term. Now what we do is we combine this minus T delta S term together. Then it is easier for me to quantify. If delta S is negative, minus T delta S term would have to be a positive term, because temperature in terms of Kelvin, it has to be always positive. Lowest possible temperature is 0 Kelvin. So there's no such thing as a negative temperature in terms of Kelvin, correct? So if delta S is negative, minus T delta S term will be a positive term. So now you notice this delta G is made up of two terms, a positive term for my delta H, another positive term for my minus T delta S, which means that this delta G term will always be positive because it is a positive term and another positive term. So this term will be always positive, and therefore the reaction will never be feasible. Only when my delta G, it is negative, then the reaction is feasible. So if my delta G is always positive, it means that the reaction will not be feasible at any temperature. So let me just write this down, not feasible at any temperature. And if the question tells me that, okay, under this condition, the reaction is spontaneous at all temperatures, it is the direct opposite. So clearly, statement number one is false. All right, so this is statement number one. Next, how about statement number two? Now, statement number two, the idea is essentially the same. We are using the exact same equation in the exact same way. If the reaction now is exothermic, negative delta H term, positive entropy change, my delta S, it is a plus term. the reaction is spontaneous at all temperatures, let us consider whether this is valid or not. Same thing, what we do is we combine minus T delta S term together because of the negative sign, which makes things a bit confusing. So if I lump it together with my delta S term, then it is a lot easier for us to do interpretation. So if my delta S term is positive, minus T delta S term obviously will be a negative term. Now you notice my delta G is made up of a negative term and another negative term. Delta H is negative, minus T delta S term, it is also negative. So negative and negative, it means that my delta G will always be negative, which means that the reaction will always be feasible at any temperature, which is fantastic, right? Which is precisely what this question is saying. For option 2, under these conditions, the reaction is spontaneous at all temperatures. So in this case, statement number 2 is true based on what we have discussed. Alright, now finally, we have statement number 3. If the reaction is exothermic, delta H term it is negative, and a negative entropy change, delta S is negative, the reaction is not spontaneous at any temperature. So let us see whether this is valid or not. Same idea here. What we do is we just combine this minus T delta S term together. Delta S term it is negative, minus T delta S term would be a positive term. And you notice now my delta H term is negative. This minus T delta S term it is positive. So I have two terms where the signs are different, correct? And what we can do now is we can predict, okay, under what temperatures would my delta G be negative and the process be spontaneous or the process be feasible. If I want my delta G to be negative, all right, basically, I want this negative term to be as big as possible, and I want this positive term to be as small as possible. But this negative term, it is a fixed value. We assume that delta H term, it is a constant at any temperature. So what can vary with temperature? Obviously, this is a positive term because inside this positive term, this minus T delta S term, the temperature is there. So you notice what we want is if I want my delta G to be negative, then what we want is we want this positive term to be as small as possible, and we want the temperature to be as low as possible. Because if my temperature is very low, this positive term will be very small. So a big negative term plus a small positive term will be negative, and therefore my delta G is negative, and the reaction will be feasible, correct? So let me just write this down. We know that my delta G is supposed to be a negative term when my T is small, correct? When my T is small, and therefore the reaction will be feasible, and therefore the reaction is feasible at lower temperature, at low temperature. Again, if I look at it in this way, when the temperature is low, T is very small, so minus T delta S term, which is a positive term, it is a very small positive term. Add to this negative value, most likely your delta G will be negative. So therefore we can deduce that my delta G is negative at lower temperature, or the reaction is feasible at lower temperature. So we have this deduction. Of course, this is not consistent with what the statement is saying. The statement is saying that the reaction is not spontaneous at any temperature, which is not true. It can be spontaneous, but the temperature has to be low, correct? So now we have run through all these possibilities. We can look through these options A, B, C, D, and we see which is my answer. We know that statement 1 it is false. We know that statement 2 is true. We know that statement 3 is false. So if I run through the options A, B, C, D, of course, the answer to this question will be option C. Alright, so that was the discussion for question 11. If you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.